Hello guys, good day. My name is Carlo Bhong Impas. I am here today to share to you the properties of real numbers. This is very essentials, especially in terms of problem solving, any mathematical problems. These properties of real numbers can help you. And of course, before we're going to start or to go deeper with our discussion today about the properties of real numbers, please let me share to you first a certain quote by Norman Brown. It says, I am what is mine, of course. And personality is the original personal property. When you say personality, that is our own or personal personality. We're going to discuss about the properties of real numbers now. But before that, let's have first the unlocking of terms for us to be guided or as we go on with our discussion today. First word is we'll have the property. When we say property, this is the abstract or the things is what belongs to or with something or whether as an attribute or as a component of said thing. Next one is real numbers. Okay, real numbers is any positive or negative numbers. This include all integers and all rationals and irrational numbers. Let's start with the first property of real numbers. We will have first the commutative property of real numbers of additions and multiplications. When we say commutative property of real numbers, changing the order of the values you are adding or multiplying. You're going to change the order, but it does not change the sum or the product. Take note the word, it does not change the sum or the product. For example, in arithmetic, in additions, 2 plus 3 and 3 plus 2, that is changing the order, but it does not change the sum, 5. 2 plus 3 is equal to 5 and 3 plus 2 is equal to 5. And in algebra, in additions, a plus b is equal to b plus a. Changing the order, and of course, it's the same sum. It does not change the sum. And of course, in also, for example, 7 plus 35 plus 13 is equal to 55. Then we're going to change the order of the numbers. 7 plus 13 plus 35, the same thing. We will have the sum 55. And 35 plus 13 plus 7 is equal to 55. And another example is 5 plus 9 is equal to 9 plus 5. We're going to change the order, but it does not change the sum. How about the commutative property of multiplications? In arithmetic, in multiplications, 9 times 4 times 5 is equal to 4 times 9 times 5. It's changing the orders, but it does not change the product. The product is 108. 9 times 4 times 5 is 180. And 4 times 9 times 5 is equal to 180. In algebra and multiplications, a times b times c is equal to b times a times c. For examples, 2 times 28 times 5 is equal to 280. And the same thing, 2 times 5 times 28 is equal to 280. 5 times 28 times 2 is equal to 280. Another example is 5 times 9 is equal to 9 times 5. 5 times 9 is equal to 45, and 9 times 5 is equal to 45. Take note the K word there. We're going to change the order, but it does not change the sum or the product of the numbers. Let's start with the commutative property of real life. For example, interchange or switch the elements. X plus y is equal to y plus x. The commutative property of real life. Think of the elements as commuting from one location to another. So you'll have the other locations, x, then plus y to the other location. So is equal to y. So you will have the the other equations, y plus x. The same thing. You're going to change the order, but it does not change the sum of the two. Next one is the associative properties of additions and multiplications, or associative properties of real numbers. It says it changing the groupings. It only changes the groupings of the values you are adding or multiplying, but it does not change the sum or the product. Let's focus with the addition, or additions and additive associative properties of real numbers. In arithmetic, 2 plus 7, it is associative. 2 plus 7 plus 3 is equal to 2 plus 7 plus 3. 2 plus 7 is equal to 9, plus 3 is equal to 12. Then 2 plus the 7 plus 3 is equal to 10. 2 plus 10 is equal to 12. So take note the word, it only changes the groupings, but it does not change the sum. In algebra, in additions, a plus b plus c is equal to a plus b plus c. And of course, in multiplications, you will have the 9 times 4 is equal to 36, times 5 is equal to 180, and is equal to 9 times 4 times 5 is equal to 20 times 9 is equal to 180. So, it only changes the groupings, but does not change the product. And multiplications in algebra, a times b times c is equal to a times b times c. Associative properties in real life, you will have friendships, of course, that's associations. The parenthesis shows that the groupings of two friends, and below, the red girl, Y, decided to change from the blue boyfriend, X, to the green boyfriend. I don't want to associate with you any longer. Notice that the elements do not move, they simply change the person with whom they are holding hands. Sana all. Next is identity property of additions and multiplications. Identity property of real numbers. The sum of any number and zero. Take note, the word, the sum of the number and a zero is the original number. And the product also of any number and 1 is the original number. For example, in addition, 12 plus 0 is equal to 12. And in algebra, a plus 0 is equal to a. That is the rule in identity property of real numbers in additions. And how about in multiplications? For example, 10 times 1, and of course, its original number is equal to 10. And multiplications, in algebra, a times 1 is equal to a, or of course, its original number. You will have identity property additions or multiplications. What returns the input unchanged? What returns the input unchanged? It does not change. For example, x plus 0, so it is equal to x, and x times 1 is equal to x. What returns the input unchanged? Identity property of real life. For example, try to remember the word I. In the word identity, variables can oftentimes have an attitude. Yes, we will have our own attitudes. I am the most important things in the world, and I do not change. Kahit pa pag-add ng 0, it will not change, and if we're going to multiply us times 1, it's equal to us. Or the same thing, it does not change. We will have the inverse properties. Inverse properties tell us that each real number has an opposite and each non-zero real numbers has a reciprocal. When we add real numbers, we will say additive inverse properties, and its opposite together, then the result is 0. For example, 3 plus negative 3 is equal to 0. 117 plus negative 17, 117 is equal to 0. For example, in algebra, x plus 4 is equal to 2. Then we're going to use the addition property of equality. X plus 4 plus negative 4 is equal to 2 plus negative 4. Plus 4, 4 plus negative 4 is equal to 0. That's why x plus 0 is equal to 2 positive times negative 4 is negative 4. So x is equal to negative 2. Then also in multiplicative inverse properties, when we multiply in a non-zero real number and its reciprocal together, the result is 1. For example, 5 over 1 times 1 over 5 is equal to 1. 5 times 1 is equal to 5, and 1 times 5 is equal to 5. 5 divided by 5 is equal to 1. The same thing, negative 3 over 7 times 7 over negative 3. Negative 3 times 7 is equal to negative 21. And 7 times negative 3 is equal to 21. Negative 21 divided by negative 21 is equal to 1. For examples, in algebra, 1/4, we'll have the reciprocal of 1/4 is equal to 4 over 1. If we're going to multiply 4 over 1 times 1/4, we will have the result is 1 or x. Then you will have 12 times 4 is equal to 48. Then 1 times 1 is equal to 1. So our x is equal to 48. Then you will have the last one is the distributive property of real numbers. We use to simplify or solve equations. For example, 3 times 4 plus 5. We're going to distribute 3 times 4. You will have 3 times 4, then also 3 times positive 5. So you have the result 3 times 4 is equal to 12. And 3 times 5 is equal to 15. So 12 plus 15 is equal to 27. And the next thing also, you will have 3 times 4x, so you will have 12x. Then 3 times 5 is equal to 15. Also in factoring, you will have 8x plus 24. We're going to separate 8x, 8 times x, then 8 times 3. Then after, you're going to copy the same numbers. You will have 8, then we're going to separate that one when you are going to factor. So you're going to copy x plus 3. You will have x plus 3. The same answer, 8 times x is equal to 8x. 8 times 3 is equal to 24. For examples, 25x minus 10. So you will have 25, 5 times 5x, that is 25x. And the common number for 25 and 10 is 5. So 5 times 2 is equal to 10. So 5 times 5x is equal to 25x. Then negative 5 times 2 is equal to negative 10. The answer is 5 times 5x minus 2. You copy the same number outside, then you copy the remaining number, 5x minus 2. Okay, by this time, let's have first a practice for us to test if you are going to know the properties of real numbers. First is 5 times 7 is equal to 7 times 5, and second is c times 1 is equal to c. And number 3, 7 plus a is equal to a plus 7. And number 4, the last item, 4 times xy is equal to 5 times x times 5 times y. Let's start for number 1. What kind of property is this? Yes, it's a commutative property. Because why? Because it's when you say commutative property, it's only change the order, but it does not change the product of each number. 5 times 7 is equal to 35, and the same thing is 7 times 5 is equal to 35. How about number 2? C times 1 is equal to C. What property of this is this? Identity property. Yes, it's identity property because when you multiply the original number to 1 is equal to the original number. So C times 1 is equal to C. That is identity property of multiplication. How about number 3? 7 plus A is equal to A plus 7. What's the answer, or what kind of properties of real numbers is this? Yes, it's commutative property because 7 plus A is equal to A plus 7. It changes only the order, but it does not change the product of the numbers. 7 plus A is equal to A plus 7. How about number 4? 5 times xy is equal to 5 times x times 5 times y. What properties of this? Distributive property, because let's say 5 times x, this will be, then 5 times y, this will be. So this is distributive property of real numbers. Thank you for listening, and again, I am Carlo Bhong Impas. Thank you for having time. I hope you will learn, or I hope you will use this one in solving mathematics problems. That will be all. Thank you.